Before we move on to a new section today, I wanted just to go back and review what we did last time. We were talking about writing equations in function form. First, we had them in the proper form and we just replaced y with f of x. But then we went to the next step, where if we were given an equation in standard form, and again, standard form is our ax plus by equals c. So our ax, so some constant times x, plus some constant times y equals c, which is a constant. So here we have negative 2x plus y equals 4. If we're putting it in function form, we want to be able to isolate y. How do we go about doing that in this problem? We add 2x to both sides. By moving that over to the other side, we now have something in function form. Y is equal to 2x plus 4. Function form simply means that we're isolating one variable on one side. Now we're going to then take function form and change it into function notation, f of x. We're replacing y with this notation f of x. So it hasn't changed what the expression is, it just changes the look. Now we want to evaluate. Let's evaluate twice. We'll start first with when f is at 6. So if we're going to look at f at 6, we're going to just replace x with 6 and then simplify the expression. So 2 times 6 is 12 plus 4 is 16. Once again, this gives me an input and an output. When I input 6, my output is 16. Let's use that same function and let's now evaluate at 10, negative 10. So we're going to go back to our function. Remember, f of x is equal to 2x plus 4. We rewrote the equation into function form. We put it into function notation, and now we're just going to take x out and replace it with this given value. The given value in the second example is negative 10. What do we do next? We simplify. 2 times negative 10 is negative 20. Go ahead and add 4 to that, and we get a negative 16. So our output is negative 16. When we input, our x was negative 10, our output, which is y, is negative 16. So that's something that we did the last time, and again, we don't want to forget what we've learned because it's going to come back in the application form in a future lesson. And it's always good to remember these things, so we'll try one more problem. This is in standard form, this equation, 6x plus 2y equals 8. We need to first rewrite it. We'll start by subtracting 6x on both sides. Remember, our goal is to isolate y. I now have 2y is equal to negative 6x plus 8. Not done yet because y is still not isolated. We need to divide everything by 2. I now have y is equal to negative 3x plus 4. I'm dividing all terms by 2. So now that I know that this is in function form, I replace y with f of x. And this is just telling me, here's my rule. Take a number, multiply it by negative 3, and add 4. So now that I know what my expression or rule is, I now want to evaluate at 5. I take x and replace it with 5. And now I simplify or just do the math. We'll multiply, we'll add, and I get negative 11. Input 5, output negative 11. We'll take that same function and we'll evaluate at 1 more point. This time negative 2. Negative 3 times negative 2 plus 4. Well, negative times negative is positive, and I get 10. So again, if I input negative 2, I output 10. we can talk about, and we will again talk about creating function tables, but instead we're just calculating at a given points. So today I want to move on to the second section in chapter 2, and that's called slope. Now slope is the slant of a line, it's the steepness. We're going to be talking about rate of change, how it changes over a particular distance. We're going to be using function form again, and this time we're going to be referring to this as the slope-intercept form of the line. Y is equal to mx plus b. It's a linear function, first degree, and when we graph it, it's going to form a line on the coordinate plane. M and b are constants. M is my slope, b is my y-intercept. So what exactly is slope? It's this non-vertical line, and it's a ratio of the vertical change, the rise, over the run. Slope is represented by the letter M. So again, I'm going to be looking at slope, which is M. It keeps moving here on me. M is equal to change in Y, and I have it on the next slide. Change in Y, which is change in the rise, over change in X, which is change in the run. Rise over run. So let's take a look at that formula a little bit more in depth. Here we'll see that we have the formula. This is our slope formula. Y2 minus Y1 over X2 minus X1. Again, we call this rise over run. It's a non-vertical line that passes through given points, and slope is a constant, so it's the same between any 2 points. Again, change, it's a difference. That's why I'm subtracting the 2. We can calculate slope as it passes through points, and let's take a look at this. We can also count it on boxes on the coordinate plane, but we're going to focus on the formula. Let me write it again, since as I scroll down it hit it. M is equal to the change in Y. Now these little numbers here are subscripts, X2 minus X1. So as I'm looking at this first ordered pair, this is my X1, Y1, and this is my X2, Y2. I'm going to just replace them into my formula and simplify. So we'll have M is equal to Y2 is 9, Y1 is 5. I'll find the difference there, that's the change. And then I've got my X2, which is 5, and my X1 is 3. The order matters on this because we want to be sure we're subtracting Y's from Y's and X's from X's. 9 minus 5 is 4, 5 minus 3 is 2. So basically I have a 2-to-1 ratio. Now that's important to know that it's a ratio because when we graph it, it's up 2 over 1. That means it's going to tell us go up, it's positive, and over 1. We could certainly state that the slope of this one is just 2 because we know when written as a ratio, it will be over 1. Let's try a second problem. Using that same formula, we're going to get M is equal to -5 minus 6 over 8 minus a -4. Y2 minus Y1 and over X2 minus X1. Be careful with your negatives. You've got to add the opposite. That's going to give me -11. And add the opposite. That's going to be 12. And my slope is a -11/12. Let's practice maybe at least one more before we end our session. We're going to remember that we can, if we need to, label these as my X1, Y1. In the beginning, I see a lot of people do that just to get comfortable with this. And these little subscripts saying this is for the first point, and this is for the second point. So we're getting M is equal to -8 minus a -7. Notice I put that in parentheses, so I'm remembering it's a negative. And I've got -6 minus 2. Here's where it's important to watch our signs. Remember, we're going to add the opposite, so that becomes -8 plus 7. add the opposite, negative 8. Negative 8 plus 1 is a negative 1 over negative 8, and negative divided by negative is positive. Easy enough to pull out your calculator to check to see if we're getting these numbers correct. And again, we'll be doing many more problems in our next section.